Okay. Thank you for coming back to us. Something wild here. Made a new experience. Sorry for this and for me. Hello. Okay. Thank you for coming back to us. Something wild here. Sorry for this and for me. Hello. Okay. Okay. So now I know what the issue was, because YouTube was recording in the background and was streaming it at the same time. That's why we heard everything double. Once live and once from the live YouTube recording, but it took me a second to figure this out. I'm very sorry for that. So we are back on YouTube, yes, but it's not going to interfere anymore. I'm sorry for this interruption. Lawrence, thank you for coming back, joining us back. It's more technical issue. But now we're going to jump right into it. We're recording, we are live on YouTube, and I want to welcome everybody. Happy to have you all back again. I see people are back, the same numbers as we had them before. I hope you can hear me everywhere around the world. Good afternoon. And again, sorry for this technical issue, but it is my great pleasure to welcome you all this afternoon. This webinar is all about timber. The mission of CPS is to develop vibrant urban developments here in Tanzania and in East Africa. Developments which are empowering and sustainable. Right next to me here, you see the model of our new generation of homes, which we launched early this year. Leander actually came from New York to launch this with us. The Visazi homes are built with mass timber in Fumba town in Zanzibar, which offers a living climate and a durability only timber homes can offer. In Fumba town, our flagship project in Zanzibar, and at the Soul, the first residential resort on the stunning east coast of Zanzibar, we are already building with timber frame technology and with cross-laminated timber. Our clients love this building material, and we want to take this now to the next level. We are planning to build amazing structures and large-scale developments here in Tanzania with timber and engineered wood products like CLT. I'm very excited to have an internationally recognized experts with me this afternoon on our panel and for the presentation about mass timber. We will discuss about why mass timber homes are the future of construction and how this sustainable building material and the new building technology that comes with it will positively impact our economy and the way we live. Allow me to start by introducing Thorsten Helbig, who will talk to us about the new timber age. Here he's waving from Germany. Thorsten Helbig is managing partner at Knippers Helbig with 25 years of working experience in the field of structural engineering. In 2001, he co-founded Knippers Helbig in Stuttgart with branches in Berlin and in New York. Since 2018, Thorsten Helbig is teaching structures and architecture at the Copper Union in New York. Projects engineered by Knippers Helbig were awarded with the renowned German Timber Construction Award and the German Steel Construction Award in 2018, and numerous national and international architecture awards. Thorsten, I'm happy you're here. I'm happy you joined your knowledge with us this afternoon. You're welcome to start and share your presentation with us. Thank you very much.
Yeah, thank you all. Good afternoon, and thank you for a kind introduction, and I hope I can live up to that, Sebastian. Thanks. So I start sharing my screen. Is that visible?
Coming? Yes, it is.
Okay, good. Mass timber. 1 second, I have to, okay, mass timber technology. So I'm, glad that you invited me to talk about this topic. It's very much a very interesting topic for us, and we as a firm, and I'm in person, we work on that for now 2 decades. And I want to give you a brief introduction and the reasons why we do this and why we are so enthusiastic about this. But I want to start with one slide I share with my students when we start talking about mass timber in class. I said I teach structures for architects, for young architects, when they start to think about materials, when they start to think about structures for the first time. And I would always claim that after the Stone Age, that was when we worked with stone and timber, before the industrialization, we used stone and timbers mainly for our houses and bridges. But then in the 1800s, steel was developed. And then in the 1900s, steel reinforced concrete was developed. And so since 200 years, timber was, the use of timber was slowing down more and more, and steel and concrete were meant to be more modern and were used in many applications. And I claim, and we claim, that since now the 2000s, 20th century, 21st century will be the century, will be the new timber age. And I will talk about this now. So why do we work with timber? For sure, because of its strong sustainability aspects. And I don't have to talk too much about this. I think everybody knows these global warming aspects of which are caused by CO2 and other emissions we produce, especially since 200 years when these industrialization started. And I don't want to talk too much about this now and too much in depth. What we all can see already is these global warming effects and all those climate change effects that just affects all regions in the world. And I think we will see in the next decades more of these effects. When you think about the building industry, about 30% of the annual global greenhouse gas emissions are caused by the building industry. And when we look at this, 28% is caused by building operations. That means cooling, heating, and so on. 72% is caused by building operations, and 28% is the embodied carbon. That means this is the material or the emissions caused by the production of the materials we use for our buildings. And when you look on the upper right-hand side, in the future, until in Europe, we now think about 2045, we will go down to zero with our carbon emissions. But it means that we would go down with this, especially with this building operations, carbon emissions. But what the material we use now will stay for much longer. That means what we now, these, let's say, gray emissions we produce now with our material, will be there for much longer time, even if we would manage to use renewable energies for our cooling and heating and so for operations. So when you think about this, the part of the aspect of the material gets more and more important. And when you look especially about this division in between structure and fit out or interior and MEP components of a building, 56%, about 56% to 60% of this embodied energy, and with that also with the gray emissions, so to say, result from structure. And when you look even closer and try to understand what causes these emissions, then you see that 20%, 22% of these emissions are caused by steel used in buildings, and that's a very general approach. And 48 is caused by concrete. So when you think about steel, it's a very simple formula. You can look it up in a chemical process. It's about 2/3 and 1/3 is about the energy consumption during this process. But at the end, you consume you emit about 1.7 ton of CO2 per ton of steel. Yeah? And that depends whether it's in Germany, in the US, or in China. That depends a bit. It varies a bit, but more or less that's the number you result in terms of emissions. Same for cement. There's about 1/3 of the cement you cannot really avoid because it's due to the chemical process, and the other 2/3 are caused by the high energy demand you need to produce cement. So, and you see the numbers, about 0.8 ton of CO2 are emitted to produce just 1 ton of cement. So what could we do? I mean, to reduce these CO2 emissions, we could use a material which do not need to emit CO2 during production, but even absorb CO2 during production. We could use timber. And what you see here is also a very simple formula, not simple, but we all should know it. Oxygen photosynthesis, that means how trees and how trees create material, right? They use CO2, water, and sunlight, and with that they create, let's say, the substance of a tree. And there's also very simple numbers you can assume how that works. 1 ton of CO2 is stored or sequestered, as physicians would say, in 1 cubic meter of timber, and it means in 1 ton of material, timber material, 2 tons of CO2 are sequestered. Do we have enough material? Yes, we do have enough timber on the world. About 30% of Earth's surface are covered with forests. And this is a number we developed for our students in New York. You see these, how many hectares of the world in the world are available for or are forest covered by forest in the world, 4 times the US land, so to say. So especially what we see in Africa is that mainly the part in the Central African region and east of Africa, we do have enough forest to actually source, or have enough sources for timber production. I've written down the numbers for Germany. 32% of Germany are covered by forest, but 52% of Tanzania are covered by forest. What is very important when you think about these, let's say, production of timber, which we would look at now for a forest, is that you have to have a sustainable forestry. That means in all those countries, you can see on the right-hand side, the forest growth is larger than the harvesting of the timber. That means than the forest production. And that's very important. So to have a sustainable forestry, we would grow more trees than we would harvest. Okay, now we have our raw product. We have timber. And what do we do with that? And now I want to talk about timber technology. In the past, we used timber more or less like this, like simple cut beams and planks. In today's times, since we use engineered timber, and engineered timber is mainly you can see as a product which tries to mitigate or reduce the typical let's say weaknesses of a timber product, and we can see it on the next slide. Oh, sorry, this is very loud. Sorry for this. Where what you do there, you take out. I have to stop this. What you do there, you take out the knots. The typical where a branch would grow out. There, you know, in a tree, there's a kind of a small failure, so to say. And when you use the timber, you produce more or less endless planks, and you take out these mistakes, these little knots, and then you rejoin these pieces together. And what it does is you kind of create an endless stripe of homogeneous, more or less homogeneous material, homogeneous in terms of parallel to the fiber. And with that base material, you can create a lot of interesting, let's say for an engineer, interesting timber products. I've shown overview here. There's many applications you could use, and the most common application, or which we know already since 100 years, about 100 years, is Glute laminated timber. That means we would glue several layers of timber together and create with that one uniform and more robust component or building component. You can bend this, you glue it together, and with this gluing process, you also make sure, even if in one plank, in one layer, there's a little weak spot, the other layers could take over. That means it's more and more industrial product in a way, but also a more reliable product than just a raw or cut out piece of a tree. And I think you all know this already, these typical glulam beams, which is used already a lot in the last 30, 40 years. You can see this in many applications already. The new thing, the new interesting thing for an engineer to use in a structure is cross-laminated timber. Cross-lamination means it's not just oriented in one direction, so each fiber is parallel, but you have it in a cross-laminated kind of arrangement. And that creates a different and very interesting product. Before I show you the advantages of this product, I show you how it's made. In today's time, this started about 20 years, 25 years ago. I think Helmut Spies can talk about this a bit more. It's now a really fully odd process where robots and CNC technology has taken over. And that makes it a very much industrial product. Yeah? I've taken screenshots from Binderholz's production line, and I think I said Helmut Spies can talk more about this. But you see here, it's fully automated and controlled by robots. And so that means also the quality control and the assurance that you create a certain precision in this process is very high. Afterwards, once you have created this product, which is a set an assembly of cross-laminated single planks, it's one uniform block, and you can then treat this block with the now available CNC technologies. That means you can cut, saw, and treat it in every possible way. And what is the advantage of this? As you like in the steelwork industry, like in the today's steelwork industry, you can work with a very high precision. So each hole, each routing for piping and so on, that's very precise in this location. And that means you can prefabricate components already in the workshop, and you don't have to adjust or recalibrate, so to say, on site anymore. That takes away a lot of risk what you would have typically on site, and makes the whole installation process much more smooth and easy and risk-free. So structurally, it's important that it can be used as a slab, a two-way spanning slab. Engineers would say it can span both directions, not just in one, like a typical beam, like this, but it can span in two directions, like a concrete slab, which is steel reinforced. But also you could use it as a wall system, because it has this cross-lamination. It means it's also, the engineers would say, shear stiff, and that means it can be also used as a prefabricated and then load-bearing shear wall system, even as a core system, so to say. Also, an advantage is that the level of prefabrication can be very high from walls or slabs, but even up to modular systems, like you can see on the right-hand side on this slide. There's room modules are fully prefabricated. That is also a very interesting approach. Prefabrication level is very high. So what about the typical things we have to talk about when we talk about timber? Timber and water, for sure. So timber is not like steel, it cannot corrode, but we have to make sure that water, even if the timber comes into contact with water, that we have to control this. I don't want to go too deep into the theoretical aspects of this, but one interesting aspect is this is a very, let's say, very, as you can see, a microscopic view of timber. What you have to avoid is that we have, like you see here, free water. So there's the cells, and when the cells, they can, let's say, absorb water up to a certain degree, 20, 25%. Humidity level, but when you have more water in the timber, then you have this free water. And that is what we have to avoid. You can actually very much control the water content in your timber product, because you dry it down to 8 to 10%. And then later on, when you use it, you have to make sure that this humidity level would not go beyond this 20 or 25%, that no free water would occur. How you do this? It's really, that would mainly happen if you directly expose the timber to, let's say, rain and to constant humidity. So basically, there's rules to avoid this. And also you can imagine like condensation effects you have to control. So you have to be careful with timber, but it's absolutely manageable. And I want to show you an example. There's buildings which are 700 to 800 years old already in the world, because they, in the ancient times, they knew about timber, maybe more than we now know, because they knew how to protect it and how to, and then also how to maintain it. In this stave church in Norway, built in the 12th century, they understood that they have a facade and a roof which needs to protect the inner primary structure. And that's the inner structure. And I said, since there's no water which would come in the inside of the building, then this timber structure can last more or less forever, right? This is now centuries old. You have to replace the facade if it's just timber shingles, but you don't have to replace the primary structure because it's protected. Yeah? There's other buildings like half timbered houses in Europe. You can still, which are 300 or 400 years old, and there's nothing, there's no degradation. Yeah? Timber and fire. For sure, timber is combustible, as we all know. Yeah, and we all know these stories from the past where these huge fires in big cities created a huge damage and losses. So the interesting aspect of timber is, yes, it burns, but it would not lose the strength. You would always, for the part which is not, let's say, which is still intact. And that's the, in comparison to steel is a difference, because steel would lose its strength. Yeah, because due to the heat, it would lose its strength, and it would actually bend more and more. So you see this example of this primary timber out of steel, primary structure out of timber and of steel. And what we hear from our fire brigades here in Germany and in the US, what they like with timber, that they can actually see what is happening, right? You see what is burning, and you can then imagine when it's burning, you see that still some remaining structure there. Yeah? And especially with this mass timber approach, where components are bigger and more massive, you can easily calculate then how much, let's say, bearing member would be still there after a certain time or let's say a certain burning time. So we actually now calculate, and this is code for in many states already, in many countries, we already calculate for, let's say, 30 or 60 or 120 minutes of how long or how much would be still be there, how much of this cross section would be still remain there and would be intact. That's very interesting. And this is for now, this approach is the code base for many countries already in Europe, but also in North America. Yeah, that means the heaviness or the solidity or having massive members helps a lot to increase the fire resistance of a building. You can imagine left-hand side, light wood construction, which is more traditional. It's much easier. It's much more risky if there would be a fire, compared to this mass timber house you see on the right-hand side. It would last for much longer. And you can imagine also when you do a campfire, you need these little sticks you would use to lit the fire, and not the massive pieces. Yeah, that's the simple base for this approach. So there's many more to say about this, but the chart zone actually insulates more or less the remaining structural member. That's the theory, and that's also what is tested several times and tested all over the world a lot, and finally led to this new codes generation, which allows now for many more applications of mass timber, not this light wood construction, but mass timber constructions, and for multi-story buildings. And what you see then at the end in these new, let's say, projects based on this assumption is that you can even, if this is a 14-story building right inside in Heilbronn, Germany, sorry, an 8-story building, that you can even reveal parts of the primary structure, which is timber, because you have this massive slabs and massive mass timber walls. Yeah? And you can then see, like here in the Visagie rendering, that you can still reveal this. You don't have to encapsulate this or cover this, that it but you can reveal this, and by just calculating the duration and making sure that you can apply these codes. Yeah, I think that's very new, and that's very interesting and advantageous for the mass timber approach. I want to show you two applications, mass timber projects. One is a student dormitory in Vancouver in Canada. And this is at the moment still the highest timber tower, so to say. And what it is actually a hybrid. That means part of the tower are made out of in a more conventional way. The core and the plinth is made out of steel reinforced concrete, but all the other levels and the dorms themselves or the rooms are made of as a timber structure. So what you see here is that, obviously prefabricated, or first the steel reinforced concrete structure would be installed and erected, and then in the next step, the prefabricated timber components will be erected. Interesting number here from what I've heard is that they have installed, each level was 1 week with 6 installers, a very fast installation process, as said, because it's a very high precise prefabrication method, and on site you don't need to adjust much anymore. Yeah, you just stick it together more or less. Here you see how it's done. Interesting details. Don't want to talk too much about details now, but it's for an engineer really amazing to see how all those components come together on site and allow for a very fast track and minimized process with minimized risks on site. So talking about this, so here you see some examples how that would look like. There's many new applications and inventions for this new mass timber approach. I think we will hear much more about this in the future. Obviously, also a key is prefabrication. Everything is prefabricated and would be just installed on site. Advantage is in the workshop, you can much better control quality. It's under controlled conditions. There's no rain, there's no heat in the workshop. You can control these conditions, and the specialists are working always on the same task, and you can really control, as said, the quality and the time. Okay, one more project which was just built 2 years ago in Vienna, Austria. It's a tower, also 84 meters high, 24 stories. It's more or less the same principle. There is a kind of core which is made out of steel reinforced concrete, and then levels and made out of, or the stories are made out of mass timber. You can see this, how it's built, how it's brought together, and then finally, as said, in a further process, you can see how much timber you can expose later on, or how much you will probably cover. That's something which always you need to develop in the design. But finally, that's the product for this tower in Vienna. There's offices, but there's also hotel area, and some stories are used for residential, from what I know. Okay, so that was a very brief history or story about timber and mass timber products. And if I can answer any questions, I would be glad to do so. And that's just an image Leander would know about the project something we thought about could be interesting, a residential tower to be developed. Okay, thank you.
Thank you, Thorsten. Thank you for this very, very interesting and exciting also presentation, but also to see, the way we build today, if we continue doing that in terms of carbon emission, we will not be able to rescue our planet. So I think there's a lot of reasons to think about new building technology, and thanks for sharing your experience about mass timber. If any one of you who joined later today missed this presentation, it's going to be live. It's currently live streamed on YouTube, and you're going to find this on our YouTube channel of Fumba Town CPS. Go to YouTube, you will find it also after this, and it will be recorded for you. Before we go into questions, I already see questions coming in here for you, Thorsten. I would like to call my panelists to the virtual stage today. And And we'll have a short panel discussion, and then of course we'll be open for Q&A and try to answer as many questions as we can. I'm very excited to introduce to you, many might know him already, he was here in Dar es Salaam in February, the lead architect behind Fumba Town, Leander Mons, who has joined us this afternoon from New York City. Welcome, Leander. Leander has a Master of Science in Architecture, Urbanism and Building Science from Delft University of Technology in the Netherlands. He has many years of experience at Baumschlager Ebele Architects in Berlin, Germany, leading architect and office supervisor there from 2014. He's been working close to us here in Nairobi with Bowman Associates and is currently working at NBBJ Design in New York in the United States as senior designer and senior associate. And recently opened a new office, a new firm in Berlin together with Andreas Strampe-Kieslich, OMT Architects based in Berlin, Germany. Welcome, Leander. CLT and engineered wood products are becoming more and more popular around the world. One of the largest players in the market of engineered wood products is the company Binderholz from Austria. Binderholz is currently expanding heavily into the US market, and I'm very glad for the CEO of Binderholz to have found time for us this afternoon in his very tight schedule. Allow me to invite to our virtual panel stage and welcome you, Mr. Helmut Spies, who's the CEO of Binderholz Mass Timber Solutions and has been in this business for more than 23 years. Welcome, Mr. Spies. Timber and introduction of this new building technology will have a great impact on our economy and the agricultural sector here in Tanzania, hopefully. That's what we are working on. To discuss more about this opportunity, I'm very honored to welcome Mr. Lawrence Mafuru, who is joining us today from Dar es Salaam. Lawrence is a co-founder and currently the managing partner of Bankable Tanzania Limited. He started his career at Standard Chartered Bank in the area of international trade finance. Lawrence has since established himself as authority in the banking and financial service sector. His varied experiences in the industry over the last 20 years includes roles as the country head of treasury at NBC, chief executive officer, managing director at NBC, and chairman of the Tanzanian Bankers Association. He's currently serving in the investment board of Financial Deepening Trust Tanzania and the board of trustees of the Benjamin Kappa Foundation. Lawrence, who has a master's degree in business administration from the University of Dar es Salaam, is a noticeable figure and sort of speaker on matters related to banking, finance, business relation, leadership, and both private and public sector. Welcome, Lawrence. We're happy to have you here today. And of course, I want to welcome back on our virtual stage, Thorsten Helbig, to discuss more about the characteristics of mass timber, making it the construction material of the future. Welcome back, Thorsten, now to this panel. I would like to start with you, Mr. Helmut Spies, about what do you think actually sparked this new timber age? You're in the industry, you're producing mass timber and hundreds of thousands of cubic meters every year, as I learned from you. What do you think sparked this new timber age and companies like you expanding now like as strongly as you do?
First of all, thanks a lot, Sebastian, for the introduction, and thanks a lot for the invitation. It's a very nice panel, and I've seen it's a lot of audience here. Yes, coming up to your question, and you're fully correct. I'm in the business now since 23 years and have seen, especially in, let's say, in the last 10, 15 years, an enormous growth on mass timber here in Europe. And it starts a lot of interest on mass timber construction worldwide now. Mainly we recognize it in North America, but in Singapore and in Australia too. And on all those countries who are interested in mass timber now, and let's say basically this huge interest in mass timber is from our point of view, and how we can define it, mainly arriving from two aspects. One aspect is the sustainable part of using mass timber. It's a pure natural product. It's a regrowing product. So our sourcing the material is in the end not a big issue. It's a regrowing product, as I said, on the one hand, and on the other hand, after reusing the material years by years, you can recycle the material quite easy. So this is an absolutely driving factor currently in using the material on one hand. And on the other hand, we recognize that the construction industry itself is more and more searching for a kind of redefinition. How can we work more with prefabricated off-site solutions? And there, timber is a material which you can use very easy for an off-site prefabrication because in the end of the lightweight of the product. So combining these two benefits and advantages of the product together is arriving in this big interest on mass timber worldwide. There are a lot of other different aspects, but this is from our point of view, the most important one.
Thank you, Mr. Spies. I mean, this is also what we have experienced. Timber really ticks all the boxes. From durability, I learned from Thorsten in one of our last sessions we had that timber is one of the few materials that actually doesn't deteriorate. Yes, I think I know for myself that in Europe, old oak wood beams that have been in a house for 200 years are resold very expensive today, right? So there is actually nothing that can destroy the timber if we build it in the right way. Yes, and of course it's sustainable, it is green, it is binding up carbon dioxide, not emitting carbon dioxide. So it ticks a lot of boxes. Thorsten, maybe you can tell me, can timber and engineered wood products from a structural perspective or from an engineering perspective really replace concrete as a key construction material today? Are we that far in the technology that we can replace concrete? We saw that we have hybrid buildings and we are also using timber. What is your idea? How's this going to be? Where are we today and where will we maybe in 10, 20 years? Can we fully replace concrete with timber?
I think that's an interesting question. We discussed this very intensely, I would say, in Europe. So I would say if Helmut Spies could deliver for the whole market, which is probably difficult. So at the moment, actually, we have a more shortage of timber in a way that, because there's a huge demand at the moment in Europe, but also in the US. And we see that actually the capacity of the timber industry, so to say, needs to grow. I think Helmut knows this. So I think that's interesting. The demand is huge, and the awareness and also interest in timber, awareness of its sustainability aspects, but also the interest in this product and the qualities of timber is huge. So can you fully replace it? I think what we have seen in these two examples is that, at the moment, the best way to use timber, the most interesting way is to use it in some hybrid ways. Yeah. So that means that for sure, as said, there are some aspects you have to consider. Humidity. So you probably don't do a cellar out of timber. You would do the cellar out of concrete. But for mid-rise and even high-rise buildings, you would always at the moment try it, especially for high-rise, you would always work in a more hybrid version. So there will be always, I think, a mix of several materials. But the big advantage of timber is, as said, this high level of prefabrication, and it's a lightweight material too. So I think on the long run, I think timber will be the share of timber in the building industry will grow more and more, I'm sure. Yeah, I don't think that it will fully replace it, but we will see timber in the next 2 or 3 decades, coming and being more used than we have seen it in the last 20 years.
Yes. Thank you, Thorsten. I mean, I have learned already that today we are building towers or residential towers or buildings in Vienna, as you show, but also I think there's a recent project in Amsterdam and in Norway, and we're planning exciting things here in Tanzania, where the timber ratio is above 60% of the building material ratio. And growing that, of course, will increase durability, will decrease the sustainability of the building. And of course, you know, I think also for tall buildings, because timber is such a light product, 1 cubic meter, I think, of concrete weighs around 2.7 tons, while a cubic meter of CLT mass timber weighs around 400 kg. So it's much, much less. So in terms of structural design, I think it creates a lot of opportunity. And this is, Leander, I think this is something that is also exciting for you from an architectural perspective. What are the advantages of designing a house with timber and engineered wood products like CLT compared to like conventional building technologies that we use today?
Yeah, first of all, thank you for inviting me here, and happy to be on this panel. In relation to like why do we like as architects this material? Of course, we come to it from the other side. We look at the finishes, and in the end, like it's the quality of the timber, which I think is really the thing we like about this material. We, of course, when we design a house, you're looking into how is your floor going to be, how is your wall going to be, how is your ceiling going to be, and with like the current like conventional materials, that always is an add-on. Like your wooden floor, your nice ceiling, your feature wall, it's something you have to buy in addition to what we have to construct. And with timber, we can make this part of our design, and it becomes a more holistic approach as such. And I think like it has been touched upon as well, like by reducing these amounts of layers, we also can recycle these products a lot easier than we can like with conventional methods, which of course like also adds to the sustainable character of the material. And I think that also for us as architects is of course an interesting point, like to think about the building and its flexibility over time, together with like the quality, high quality finishes of the material is for us makes a big difference in relation to conventional methods of construction in terms of what we can then create of architectural quality inside the buildings. So we are very happy to be part of like this wave and this like approach with constructing with timber. And the more projects we do, the more viability we see in this material, and we try to work with it in different means to create really interesting architectural finishes and projects as a whole.
Yes, I think that there's a lot of opportunity, and we've seen what we are doing already now in Zanzibar and what we have in the pipeline coming to Fumba and other projects here also in Tanzania. I must say from my own experience, which is not too big, but I remember the day I stepped the first time into a CLT home in Cape Town, and it just felt so nice, and the smell and the climate in the house, you know, being surrounded by nature. I think it gives us everybody also a very exceptional living climate and a living atmosphere to be surrounded by nature in your home all the time. So of course, you know, our target is as a developer here in Tanzania to attract global players to come into this market and build with this technology already here. Because we have a lot of timber. Thorsten showed in his presentation, 57% or 52% of Tanzania is covered with forests. Mr. Spies, Bindenholz is one of the biggest players in the mass timber industry in the world today. And I know you're currently expanding into the US market. Would you be ready, or would it be considerable to expand into the African market? I know Africa seems very far away for many European companies. And what would be required? It doesn't matter where now, maybe in the US or in Tanzania. What would be required from a production point to enter a market like this, Mr. Spies?
Generally, you know, we as a Bindenholz group are interested in each market where we can help to develop mass timber structures. This is one thing. So there we are talking about sales and engineering and service and support and the system marketing using mass timber. This is one part of the story, let's say. The other part is start a production line. And producing mass timber, mainly we are talking about cross-laminated timber and glue-laminated timber, so GLD. That means if you want to really produce these products in a profitable way, you need a minimum volume in an annual production. When you produce, let's say you run your factories in a 2-shift or in a 3-shift, so 16 hours a day or 24 hours a day, then you need a certain volume which needs to be fed in the factory every day. And this is quite a lot of volume. So you need to have a market, first of all, a local market before you start a production. And when you start a production, it is not just, this is the philosophy of Binderholz. This is not a general philosophy of the timber industry. If you start a mass timber production, you need to create a vertical, fully integrated line on different factories. So you need a sawmill, you need a biomass power plant, you need factories or installations on site. What are you doing with the rest of the timber, which you can't use on material based? And then which board is used best for a cross-laminated timber, which board from the tree is used best for a glue-laminated timber, and which board makes more sense to use it in another part of another product, or in example as a board for facading industry. So, and this is the reason why Binderholz has quite on every factory where we are and on every site where we are, very vertical integrated philosophy that we are sourcing the timber in the harvest. This is where the whole story of the binder industry starts. And then we process the tree vertically through our factories with a no waste philosophy and end up in mass timber products and building solutions. So this is, from our point of view, an important factor that needs to be given. How big is the market? Because when you have a certain volume of consummation of a mass timber in a market, you can start to think about to run a factory. So why not? We don't say not investing in example in Africa, but you need a certain volume continuously around different years arriving, and it makes sense to install a factory.
Yes, thank you, Lawrence. I mean, you know, here us being in Tanzania, we have the forest, and we just learned its volume, yeah, and I'm sure markets. What would you think? What would it need to stimulate our forest industry here in Tanzania? And we have massive forest reserves. We have a huge demand for housing, for instance. Yes. What do you think it needs to stimulate this market and to spark it and get it off the ground and produce these kind of volumes Mr. Spies was talking about?
Well, thank you, Sebastian, for having me on the call, and thank you everybody for those insightful presentation, and especially to you, Thorsten. You know, listening to your presentation when you started, I just concluded this is a story of, you know, you've been to a place where people wear shoes and you think there's a market for shoes, or there isn't a market for shoes, or simply decide to say, look, I don't think I will have a market in this country because there's no interest, because there's no usage of timber or forestry the way it is used in your market. I think you know, going to Sebastian's question, I think the reserves that we have in the country are sufficiently enough to really start the industry and grow it. Unfortunately, this sector is lumped into a sector that is also not given full attention. This sector is called agriculture. So most of the time, people talk about agriculture, you will have to find within agriculture where is forestry. And so, but, you know, given the numbers that we're seeing, you know, the numbers that you guys are talking about, this should be a standalone industry in its own, probably pushing our GDP contribution, our export numbers to a much higher number than we're currently seeing. But it suffers from a common problem that the entire agricultural sector in Tanzania is suffering, which is productivity. So I think it's Helmut who just mentioned about sustainability and ability to produce in a much larger scale. So it talks about reforestation. I think we do see that there is forestry, yes, but when you start planning for massive and high scale usage, especially in the building construction space, and using timber as the only building material or a significant building material, you begin to get into a problem of having sustainable programs of reforestation, making sure that there's reproduction across many years so that it becomes a sustainable industry. But even more importantly, the potential that lies in the sector is massive, in the sense that I had a no waste philosophy here. In Tanzania, I am told that we only use 40% of the produce of the forest. So if you look at a tree, it's only 40% that is being put into economic process. The remaining 60 is waste, and I think that's almost leaving money on the table. So I think the potential is quite large. One thing that we need to start talking about is, why would timber be the construction material? And for people to begin to see that, we do have a conundrum here where there's two lines of education that needs to come through. One is, let's look at timber as a construction material because it will help us achieve quickly these sustainable development goals of preserving our environment. So that has to become a priority amongst the people and the government here in Tanzania. And number two is, once that happens, it's just not about preventing our environment, but it's about opening up a new source of our economic growth. Tanzania's poverty alleviation is meant to come from the agricultural sector, and where timber or forestry is also clustered. The economy has to grow at around 80% for the next, let's say, 5 to 10 years. But then agricultural sector is growing at a lesser rate. I think it's around 4 or 5%. So it's even growing lower than the average growth that is needed. But then looking at the potential that exists, this has a potential of growing double digit and pushing that economic growth even more higher. So there is a huge potential, to answer your question, but I think there will be some work that will need to be done to bring the value chain together, to get the forward and backward integration, or the vertical integration that has been referred to, for people to begin to see that a raw material from one stage and producing the waste on the other becomes a raw material for the next stage. And therefore each value chain creates some value. At the moment, we're leaving a lot of value on the table.
Yes. Thank you, Lawrence. And this is exactly true. And that, talking about the volume, on the other side, we have to create a demand we have here. We need to grow, and the agricultural sector not bringing that on the table what we have to. I think using and stimulating the forest industry and the construction industry using these materials can really help. But Thorsten, then I'm asking you now, stimulating the timber industry on one side leads us often to change of the perspective about timber that many of us still have. I'm facing a lot of people when I talk about, we're building timber houses. They think this is old-fashioned building material that is not up to date. The durability of timber construction often concerns our clients. What can you tell us about that compared to concrete, for instance, which is the most common building material we have here? We shortly discussed this before, but clearly comparing mass timber to concrete in terms of durability. What can you tell us from your experience there, from the scientific know-how?
I think there's an interesting perspective on this. When you look at these old houses like half-timbered houses in Europe, or the stave church we have seen in Norway, or you know, on every planet you can, or every continent you can find examples of, you know, of old craftsmanship, and this times, you know, the carpenters would know how to treat and how to protect the timber, and then the buildings would be maintained. So you can, as said, you can find very old buildings and even old bridges in Europe which are 300-400 years old. I think why is there's in let's say in the last 30, 40 years, 50 years, timber was more used in a light frame construction kind of type, right? So it was often not very carefully planned and constructed. So, and then a lot of, due to the humidity and fire, as said, it was, you know, it was kind of seen as a not that high quality building material. So because there was a lot of issues with that. So I think with this new approach, mass timber approach, and with with these increase or development in production, but also in a more careful way of designing it, you can again deliver houses and other components which are more durable. So I think that's very important. I think designers, producers, and others have learned about timber more, right? And as said, the modern product we talk about now, I think, in my opinion, as an engineer, but also as a teacher at the architectural school, has a huge potential. And there's the innovation steps at the moment are huge in timber industry. Yeah, as said, steel and concrete that happened in the last 3, 4, 5 decades, but timber and the modern timber development happens right now, and I think that's interesting to see and interesting to be part of this. So, as from a technological point of view, so I think in terms of we talked about how durable is timber. As said, theoretically, it can last forever, so to say, because there's no corrosion. There's no, like for steel, you have to protect steel, you have to paint steel. And also for concrete, there's a process, you know, you have to protect the steel, the reinforcement, by a kind of a thick concrete layer. And over time, these concrete layer would protect in the first place with a kind of a passive action, so to say, the steel bar, because the steel bar is not painted, not protected. So after a while, this passive, let's say, protection of the concrete would go away. So we talk about 60, 70, 80 years. That means a lot of bridges after 60, 70 years, the steel reinforcement starts to corrode. And that's something which would not happen with timber, yeah? And that's a difference. So I think over time, in the next 2 or 3 or 4 decades, we will see that timber used properly and, you know, can be more durable than steel or steel reinforced concrete. And I think that's also something we have learned as designers and as in the building industry, producers, manufacturers, and so on, how to deal with these old/new material. I think that's a very interesting aspect.
So basically understanding, I think this is something that we need to tell people, is that it's a very old material, known for decades, for centuries.
For centuries.
But it's a very new technology they're implementing today. Yes. So it is in the end a new building technology, a new building material, engineered wood products, CLT, glue laminated timber, that has been existing before, that creates this kind of efficiency and also living climate and structural strength.
Yeah.
You know, I think the code, we have buildings up to 100 stories now. Above 20 stories are now encoded in international codes, the US code, the European code. So this is quite amazing. And it's very important for us. Thorsten, you want to add?
Yeah, maybe one more comment in terms of structure. I think timber has a very advantageous ratio from self-weight and strength. That means it's, when you compare this with steel, it's also very good, but concrete, as said, is very heavy finally, and the load compared to its load-bearing capacity, it's actually lower. So in a way, you can like for a slab spanning over a typical distance of 6 meters, a timber deck could have the same thickness as a concrete deck, but it would be the concrete deck would be 5 times more heavy, yeah, because of its self-weight, specific weight, so to say. That means there's a huge advantage to this when you think about you have to transport those materials, you have to install many stories. That means what is the self-weight of a structure acting onto a foundation and onto the soil, so you can also save a lot of let's say foundation construction, so to say. And also, maybe to talk about durability, we also design and build timber bridges again, using these, let's say, findings of the last 10 years or so, how this is used now based on the mass timber approach. And we can see that these bridges are more durable than the bridges we have done 30 years ago, because these bridges have, are not mass timber bridges, but trusses and, construction types which are more prone to, let's say, or more difficult in terms of humidity and dealing with humidity. If you have, as said, the very simple story is, if you have a massive building component out of timber and no little details where humidity and water can, come into and could go away again, then humidity is a problem. But if you avoid this effect and you make sure your structure, your timber structure is protected and humidity cannot, let's say, cannot be there for longer. You remember this free water in the cell. If this cannot happen, your timber structure is durable and can stay there forever.
It lasts forever. I think this is a great sentence we have to keep in mind, that durability of timber is amazing and exciting to be part of this new technology coming into our industry as well, and with the potential also stimulating local agriculture industries in countries like Tanzania. Leander, just very shortly, because we're already quite far down our timeline. What do you feel are the advantages of now, we're selling houses, we're developing vibrant urban developments here in Tanzania and East Africa. What are the advantages of living in a timber house and compared to a building constructed with conventional materials like steel, cement, or concrete? What do you think from a living perspective? What do you think are the advantages that
Yeah, exactly. So first of all, it's of course the atmosphere we create on the inside, which is like, because of the natural material, a different one than when we have like just white finishes and gray finishes. So the house comes with an atmosphere with its own character, right, when you step into it. And you mentioned it before, you step into your first CLT house and you didn't, or you still know that experience. And that is because, like, of course, especially in the East African climate, which is very humid, very warm, we are not relying on any like wet materials for construction with timber. So the house is dry. It is like as it should be when you occupy, when you step into it right after it has been constructed. Of course, with like more conventional methods, especially with cement, plaster, concrete, that house needs to dry out, and the climate doesn't support that dry out. It will take out a long time, especially in the East African context. So there, of course, for new housing, and we all heard about like the need for housing, which is there. This is a very good material to use and to create very good living conditions right from the start for the people in East Africa. And I think that is also something, especially with this this high demand for housing, which will drive up this approach as well for new projects.
Yes, thank you. I agree fully, and I know also one characteristic is, of course, the cooling effect we have. Typically, it's quite hot. Here it's very humid, but it's also very hot, and the concrete absorbs heat while the timber does not. So cooling our buildings, I think, is also a huge advantage there, yes, to compare to the conventional structures. I know, Mr. Spies, you're in a rush because you're very busy this afternoon. Just one more last question from your experience. Yes, and we discussed a little about what would be necessary to come into other markets. You talked about volume. But what other requirements have to be there? What are the key requirements to develop a mass timber industry? We didn't develop those 20 years, 30 years ago in Europe. What were the key requirements that had to come into place besides the volume and the demand that somehow came into place to develop a mass timber industry?
Okay, coming back, very important is, as Thorsten said, you need a demand. It is always arriving from the market. If you don't have a demand, if it is not given, that it is, let's say, fairly probably traditionally in use timber, it is not easy to start the industry. What we learned in the Binderholz group is, first, you need to arrive with the demand and with the market, and then you can install an industry. And then it comes itself, because beside creating a demand in the market, from our perspective, very important is the training of consultants companies. This is what we recognize quite often. You need to train and teach on university, on high schools, the engineers, the architects, the installers, the quantity surveyors. So it is not given automatically if interest is there from a government or from an investor to work with mass timber, and if the industry is arriving and investing into into a factory, that then automatically a huge volume of timber construction will be constructed, because you need to close on the knowledge how to use mass timber from the beginning on, which is basically the architect. And then, construction is a chain, and you have different parts of the chain. And it starts with the architect, then it comes to the engineer. The quantity surveyor is very important. You need to have the industry who's producing the mass timber, but then the installers. And that's another very important topic. There, we as a Binderholz group, we are very, very focusing on training installers and general contractors to work in a right way with mass timber, in the same way how they do it with steel and concrete, so that this knowledge is given how to install it in the right way, how to work with timber in a correct way on site. As Thorsten said, the water management is very important, and some other important factors. And then the usage of mass timber can grow. So training, conferences, and universities and high schools are with more professors, with more teachers who train and teach how to use the timber in the right way. That's very, very important, beside creating a market from the industry itself.
Yes. Thank you. I think that is really interesting. So it's not only the volumes that have to be there, but we have the whole value chain, from the consultants to the students learning about timber, professors teaching about timber, like Thorsten is doing in New York and others. So assuming that we can use a lot of that knowledge that is already in the world today, Florence, yeah, hearing about today a lot about the advantages of building material, of this building material, and opportunities that come with this fantastic material. What impact do you think mass timber technology can have to build a strong housing sector in Tanzania? You have a huge housing demand, you have forests, you have experts, which knowledge we can use. We are starting to talk about it like this afternoon. Of course, there's a lot of gaps still, but do you see the opportunity for the housing sector in Tanzania using this building technology?
I think there is, but we will need to deal with a few issues. And I think for me, listening to the conversation and following the market here, we do have both demand side and supply side issues in country. I'm sure if I ask you, Sebastian, part of the timber you're using is imported. And the reason you're going to tell me why you're importing, it's because it's expensive to source timber locally. So that talks to the supply side challenges that we still have to get to efficient levels of producing timber, so much so that we can have a local market to start with. Because the fact that you're still, importing some of this really threatens somebody to invest in Tanzania. So one has to dig down and understand what is driving that supply side challenges, which is making the sector inefficient to the extent that it's not attracting a local or domestic market. And then, of course, on the demand side, I think somebody was asking, and I think you need to watch on the questions on the side. I think the skepticism of sustainability of timber or wooden houses comes with a lot of questions. Somebody asked about timber and timbers, and obviously the fire issue came in as well. So I guess for me, it is bringing the two sides together, in which case we need to really make sure we deal with production in terms of reforestation. Processing capacity must be developed. I think there's a need for improved infrastructure in the areas where the forests are. So that will probably bring down the cost of production and making the final product a lot more affordable, in order to create the demand on the other side. So the impact is definitely there, and it's double win, in the sense that it will drive the economic activities and therefore economic contribution, but even more importantly, it will improve the living conditions environmentally. And this, sometimes it's not easy to see or to attach a dollar value on improved living standards. But when you start seeing extended life expectancy and people being a lot more healthier, then you begin to see the value of this side. So just to wrap up, because I know we're conscious of time, we need to address the demand and supply side, because I think there's both areas that needs to be addressed within the country. Value addition, value extraction. Mo Vesi was reminding me that on the 40% that is being utilized in Tanzania, a portion of that is actually used as energy source of energy. So even more adding the production of carbon emissions, because it's used as charcoal for cooking. So again, I think we need to make sure that there's good use of timber or forestry, and therefore begin to address the economic and the social benefit that can come. So there's two types of benefit or impact, social and economic, but we have to really bring the value chains together and see how they can be integrated in a much bigger picture of the industry, and perhaps begin to measure the industry on a standalone basis, as opposed to where it is currently hidden within the bigger sector of agriculture, and it's difficult to see its growth and its contribution to the economy.
Thank you so much. Thank you so much for these last words. I want to thank you all. We've learned a lot today. And of course, I would love to keep on this discussion much, much longer, but we have a lot of questions here we would like to still give a chance to answer. We understand that it's a beautiful building technology. It's not the timber that we've been building 100 years ago. It's not the same way we used to have timber. The mass timber construction technology today is a new technology, a very durable technology, and with a beautiful living climate for houses that works especially well here in the tropics, where it's very humid. Producing it here, getting mass timber production companies like Winterholz to attract them to come to invest in Tanzania, to create demand. We have to work on a few issues still in the country, not a few, quite a few issues. We are here to do that. I know Lawrence is here on our side. Thank you also, Mr. Spies and then Thorsten and Leander to be with us here today, because it's really at the heart of us, CPS, our company, the projects we do to push this development also into the Tanzanian market. We need to build a lot of houses in the next few years, and we should do it with the right building technology, the right building material. This is really what we want to achieve, and this is what we are getting up for in the morning. This is what we're working hard for. There's still a lot of work to be done, but we are very optimistic. We are doing it already. Not because we are planning to do something, we're already building with this material here in Tanzania, in Zanzibar. It is selling. People love living in our houses, in the timber frame, in the CLT houses, and we're going to bring it now to another scale in our new developments and to new designs and heights in our projects here in Dar es Salaam. So thank you for your time this afternoon. I know all your schedule is very full. Thank you for joining us and supporting us. If you still have time to stay for a few questions, you're very welcome. I would start here, and you're seeing them also on the side. Please feel free also to pick a question if you feel there's something that you really specifically would like to answer. But I have two questions here from people following us on YouTube as well. People, Laura is asking, is this way of building sustainable really? I think people, and we saw that question of Lawrence, you saw that on the side, people are still not very certain is, we're using timber. Of course, it's, how can timber be sustainable? Because, we're cutting down trees. Thorsten, maybe very quickly, Mr. Spies, very quickly. How can a sustainable timber industry be built? Or what does it need to be sustainable?
Maybe I start, Helmut. I think, first of all, it needs to be based on a sustainable forestry, as said. It is key, and I think that's, when talking to my students, we talk about this 200 years of history of sustainable forestry in certain parts of Europe, and that means just that you have to plant and you have to grow more trees than you harvest, right? That means, that actually the forest grows over time and would not be smaller, so to say. So that's very important. Secondly, when you use the timber, and you would always substitute other materials which are much more CO2 intensive, so to say, right? We talked about cement, which is which emits a lot of CO2, or there is a lot of CO2 emission during its production, but also steel. So you omit these. You don't use these materials. This is two effects, right? You absorb CO2, but you also substitute other CO2 emissions. That means when you do a life cycle assessment, what we do for our projects already, then you can always calculate that with these timber approach, so to say, you would always come up with much smaller numbers of CO2 emissions. And then thirdly, I think that's a discussion we have in timber already, is that how could you recycle timber? Yeah, you could use the same component again, and you could, the traditional way is more or less to use it as an energy source. But even if you burn the timber, then, like Lawrence said, you'd also avoid oil or coal. So that means even this brings you an advantage compared to other energy sources. And what we discuss at the moment is that you could actually recycle the timber on the same, let's say, level, not to downcycle it, but actually to reuse it, let's say, more or less for the same purpose. And when you think about the other materials, steel, you would also melt it again to reuse it. You would not exactly take the same beam and to reuse it in another building, but you still have to use an energy to heat it up, yeah, and you still have to emit CO2 to reuse this material. And for concrete, actually, you cannot directly reuse it. You would just use it as an aggregate again, because it has the cement action, so to say, the hydraulic action is not there anymore. That means you cannot really reuse it as concrete, but you have to, you can't use it as a aggregate to the next use. So in a way, I think we are close to, and maybe Helmut knows more about this, Helmut Spies, about really recycling the material instead of just burning it. So, and I think that would be also the next level, so to say, of recycling of timber.
Adding to the sustainability.
Yeah, but Thorsten, there is nothing to add. It is exactly that what I would have been answered. From my point of view, the only thing which we need to, what could be added is to develop technologies, how to connect the timber parts together, that after maybe 50 years, 60 years, 100 years, when this component or timber part is used in a building, that you can easily deinstall it, ship it back to a shop, and then there you redesign it, you reprocess it, and then use it new for another structure. That's, from my point of view, another very interesting topic. How can you design the usage of the material in one building that you can reuse it easily in another building? That's something which all who are working on a building, is the architect, the engineer, the industry, the installer should focus on. This is what we are very, very focusing on. But nothing to add, Thorsten.
Yes.
Thank you.
Thank you. So I think to answer your question, Laura, this is really an extremely sustainable, like not the most sustainable building material you can use if you do it the right way. Yes, if we source it in the right way, if we source it from forests that are going to be reforested, that have the right biodiversity, and we're controlling the demand for timber from the industry, we can of course also then say or restrict our supply from forests that are doing the right reforestation and planting enough trees, typically more trees like we saw in those countries that we had in the diagram at the beginning, that are actually being used. So the forests are actually growing by using it in a sustainable way. Maybe that is a question. Now I have a question from Elisa here from YouTube. Lawrence, from a Green Building Council, how carbon buildings are encouraged? How are the carbon neutral buildings encouraged? Is there a factory in the region, or are the factories coming? What is being done to encourage this technology? This is what I understand from a green building point of view. Is there anything being done in Tanzania already to encourage this way of construction?
I think, as I started earlier on by saying, one of the things that we need to do aggressively as a country is to start aggressively the education on green building. It's not something that we're talking about much here. There's a lot more on carbon emissions when it comes to fuel and other sorts of carbon emissions, but very little in terms of how we can address, or rather reduce the problems by green building. And I'm hoping with your initiatives, Sebastian, on these timber wooden houses that we're talking about, should probably trigger the conversations around that. But I'm not seeing a lot happening, and I think that's where the opportunity is. I will repeat what I said earlier. There are no people wearing shoes, and therefore there's a huge market for that, starting from all these encouragement of people beginning to look at green building as a way of preserving nature and improving our livelihood on planet Earth.
Yes, thank you. So I think this is a whole awareness issue, education, and also what Mushbi said before. There's a lot of things that have to come in place, from education to consultants to contractors to government, the whole value chain to promote and create this demand in a sustainable way also. From a development point and with the opportunity of doing large-scale developments, we want to play a central role in doing so in Tanzania. And this is also why we are promoting this today, and why are we working and trying to learn from you as our experts how to do that, and do that, and not only learn as a developer, but learning together with our clients and people around us and potential clients and our government and authorities and contractors. There's a lot of contractors today listening here, Mr. Spies. I know them. They are part of this. They're interested to see, is this maybe a way we can go? Should we train our people to learn how to use this technology, installer teams, and so on? So there is a huge interest in the market, and I think we can really move this very fast. Just quickly, I've seen somebody asking, is this being this video someday accessible? Yes, it's on our YouTube page. I've just shared that link. You can access this video anytime after. We're currently streaming live, but after the live stream, this will be accessible on our YouTube page. Thorsten, I think you need to help me. There's a kind of a complicated question here. Salim Shaban is talking about the hygroscopic nature of wood, and what need to be done to take care of this nature. Can you maybe say one or two words about that?
Maybe, yeah, that's always the discussion we have, like when you work in, let's say, tropical environments, so to say, like and we, Helmut already mentioned projects in Singapore. We have talked about a project in Myanmar a year ago, and there's, but also when you think about this, what is very common is that we use timber roofs for indoor pools, right? Where you have exactly the same high humidity and kind of a high temperature, and it shows, what you can see is that due to this massiveness, the section will just the outer region will be affected by this, by this change of humidity. So I think that's also an interesting aspect of mass timber and we did a lot of testing and measuring the humidity inside of very massive timber bodies, and you can find always that it's just really happens a change in humidity over time in let's say the outer 2 or 3 centimeters. That's very interesting. That means the heavier, the more massive such components are, the better it is. But at the same time, as said, we always talk about humidity as an issue for timber, but just when the humidity level is in the body of the timber above 20-25%. And that, as said, the timber arrives with, Helmut, please correct me when I'm wrong, 8 to 10, 11% of humidity level in the timber because it's technically dried down. Yeah? And so that means the whole body of the timber arrives on site very dry, so to say, and it reacts very slowly. Yeah? Helmut would talk about the situation on site when there is the timber is exposed, and then during the installation the rain would come and they work on this and they have to avoid this, they know it, but afterwards under use it needs to be fully protected, and that's what you have to take care of. Yeah, you're building your bridge, whatever you do with that timber, you need to make sure that you construct it in a way that humidity is is not exposed to rain, that's not exposed to, let's say, constant humidity, so to say. And but if you do this, as said, your structure can last forever, more or less, right? Because there's no, let's say, degradation, as you mentioned, there's no corrosion, there's no other effects. So this is, to the question back from Salim, I think that was investigated for quite a long time, a lot of studies, and all those studies proved and could confirm that, even used in such a kind of tropical environment, timber is durable and would not increase in humidity inside of very massive timber sections.
Thank you. Maybe another question that comes quite often, which please maybe you want to answer that. I'm not sure if you have a similar question coming to you in other places around the world, but this comes here often. Is the timber or the mass timber protected against termites? We have of many regions here a lot of termites. What would be, what's your experience with that?
Yeah, originally or normally it is not protected against termites, but there we have a so-called tip impregnation, and then it is protected against termites. So when we deliver in regions where it can be affected by termites, then it can be ordered with a so-called tip impregnation, and then it's protected. Yeah.
Thank you. So yes, it can be protected. What we also do is already in Zanzibar is that, of course, we use protected or impregnated wood, but we also pack it, so it's not often exposed to the outside, and we're of course lifting it from the floor. So there's also very manual processes to protect against termites, but of course it needs to be treated, and then it is very safe. All the houses we built many years ago in Zanzibar and Fumba with timber are still standing and not being affected by any termites. So it is absolutely possible. This question comes very often. And let me quickly see what we have here. I had a question, I think, Lawrence, I would like you to quickly talk about that. It's of course, people are afraid that, we're bringing this technology. Vera's asking here, are we going to plant some trees before we're bringing in the technology, or what is happening? So people are afraid that, we're bringing this technology and then we're suddenly going to cut a lot of trees. I know there's a lot of trees, and I know people from the Forest Development Trust of Tanzania are listening also today, and there's a lot of forestation happening already. Can you take Vera's worry that about planting trees today? What is happening? You know a little bit about the market. How does the timber market look today in Tanzania? The forestry market, sorry.
And so I kept repeating myself on reforestation, the need to reforestation. The moment we start, aggressively utilizing and opening up this industry, definitely there'll be pressure on the reserves, just like any other, renewable source of production or energy. I think we'll always need to create an environment that it will be continuously be available there. So I think with forestry is the same. It will take a lot of planning, and therefore they will need a lot of concerted efforts from all parts private sector investors being able to invest part of the money that they were generated back to the production line, which is growing more trees and more forestries as part of replacement. So for the industry to be sustainable, there must be very clear and sustainable plans that will ensure that the supply is guaranteed for many years to come.
Yes, and I think with a very structured demand coming into the market, this can be arranged. I know there's a few big players already in the market here in Tanzania that are in the forestry industry, that are reforesting, they are planting trees, they're selling trees, timber as a product. So this is already being done. But of course, Vera, this is something that we have to very carefully look at. Let me see if I find one more question, and then I think we're already very far down the line. We won't be able to answer all the questions. So I think we have answered most of them, or most of these points already in one way or the other that I see here in the line. Sorry if we maybe haven't answered your question directly, but our time has come to an end. I want to thank everyone for participating this afternoon, for attending this. Thank you very much. Thank you again to my panelists and to the presentation of Thorsten presenting about mass timber. Thank you, Helmut Spies, for your time this afternoon. I know how tight your schedule is. Also, Lawrence and Leander for sharing your thoughts and insights into the market. As CPS, we are excited to be in this path, on this path with this, and in the development of this technology, using it already, and promoting this technology here in East Africa. And we're looking forward together with our clients, with the government, with the sector, with the private industry, the public sector, to push this market forward, to push forestry, to push the use of mass timber as building technology. And I want to thank you all for joining us this afternoon, for your support. And yes, please visit our YouTube page, our website, our Instagrams, our Facebooks, and follow what we're doing. Exciting projects coming. I can tell you one small thing at the end. We're planning an amazing project in Dar, which is currently already in schematic design. We're going to hopefully launching this end of the year. That is going to change the way we think about timber for sure in Tanzania, in Africa, and will bring us onto the world map of this development. Thank you, everybody. Thanks for sharing, and thanks for your time. Have a good evening. Have a good night or morning in New York. Yes, and see you all soon again for taking this further and taking this vision to the next level. Thank you.
Thank you, Sebastian. Thank you, everybody. Bye-bye.
Thank you.
Bye-bye.